1. So we've gone through the getting triggy with it, which was kind of our lead-in activity and a bit of a geometry refresher. It's been a while since you had done any right triangle trig in geometry. Okay, so here, this first key concept box is listing 6 trig functions, 6 trigonometric functions. Okay, 3 of them you should be familiar with, or they should look familiar to you, because they are the ones that you learned in geometry, and they're the ones we were kind of reviewing yesterday with the getting triggy with it. So sine, cosine, and tangent, you should know those ratios in terms of opposite, adjacent, and hypotenuse. Okay, so what are they? What's the sine ratio? Yep, good. What's the cosine ratio? Yes, very good. And tangent? Good. And how do you remember that? Okay, so in this section down here, this blank section, you may want to jot down whatever memory tricks or side notes that you need to help you learn that by memory. So SOHCAHTOA is the most common one. Okay, sine is O over H, cosine is A over H, tangent is O over A. Okay, but there are some other mnemonic devices that you may have seen or heard. You can make up your own little sentence. One that I've heard another teacher use was Oscar had a heap of apples. So that's OH, AH, OA. That's the order of those. OH, AH, OA. So Oscar had a heap of apples. SOHCAHTOA. You can make up your own little sentence. There's one that I'm not going to write down because I don't want to get in trouble, but I've seen another physics teacher use it before, and it uses all of the letters SOHCAHTOA. It's some old hippie caught another hippie tripping on acid. So if that'll help you remember it, I don't care what you use as long as you remember it. Okay. So SOHCAHTOA, Oscar had a heap of apples, make up your own. I don't care, but you've got to know those ratios. Okay. Now on the right, these are 3 new trig functions. You have not seen these 3 before. Okay. This is this is pronounced cosecant. Cosecant. This is secant and cotangent. Okay, so the abbreviations are CSC for cosecant, SEC for secant, and COT for cotangent. Girls, put your phones away and be quiet, please. So you can use these abbreviations for these new ones. Now, the relationship for these new ones that you haven't seen before, it says right here, cosecant, secant, and cotangent. These are reciprocal functions. Okay, who remembers what reciprocal means? Opposite what? What do you mean opposite?
Opposites of.
What's changing when you have take a reciprocal? What do you flip? What do you switch? In a fraction, you flip the numerator and the denominator, right? Okay, so that's what a reciprocal is. So you can see cosecant is the reciprocal of sine. So it would be equivalent to 1 over sine. Because if I take sine and I flip it, it's 1 over sine. Does that make sense? Secant is the reciprocal of cosine. So it's equivalent to 1 over cosine. Cotangent is the reciprocal of tangent, so it's equivalent to 1 over tangent. So in terms of O, A, and H, you just have to flip the fraction. So cosecant is the reciprocal of sine, so its ratio is H over O instead of O over H. So secant would be what? h over a. And cotangent would be what? Very good. So the most common mistake in this for the reciprocal functions is forgetting which ones are reciprocals of each other, which ones are paired together. A lot of people want to put sine with secant or cosine with cosecant because they start with the same letters. So make a side note somewhere and just make sure you understand S goes with C. So sine, cosecant, cosine, secant. Okay, don't flip it around. They don't match by letter. Okay. And then tangent goes with cotangent. It's literally got the word tangent in it. So that one's usually not flipped around very often. It's usually these two that get mixed up. All right. Now, another relationship besides the reciprocal identities, reciprocal relationship, is this. These are called quotient identities. Quotient means what? Operation. What are you doing if you're finding a quotient? You're dividing. So there are two trig functions that when you divide them, it gives you another trig function. And that's sine divided by cosine is equivalent to tangent. Okay, so this is a quotient relationship between those. Now I'm going to show you how that actually works out. So I'm going to do sine divided by cosine. So the sine ratio is O over H. And the cosine ratio is A over H. Now you've got fractions in fractions, right? Not pretty. What do we do when we divide by a fraction? Flip and multiply. So remember that some of your teachers may have used the little memory trick. It's dividing fractions as easy as pi. Flip the second and multiply. So the second, that's the denominator. So you flip the denominator and you multiply instead of divide. So flip and multiply. So then when you're solving this, you've got O over H times H over A. What happens with those H's? Yeah, that reduces. Okay, so then you've just got O over A. And what is O over A the ratio for? Ah, tangent. So sine divided by cosine does indeed give you the tangent ratio. Okay, so that's a special relationship that's going to come in real handy this year when we're doing all of our trig. Okay, now if that's true, if tangent is sine divided by cosine, then the reciprocal must also be true. The reciprocal of tangent is cotangent. So that must be cosine over sine. See how they just flipped it? And that one's also true. I'm not going to go through showing that it's true. You can if you want, but it works out the same way. When you work it out this way, it comes out to A over O, which is the reciprocal, which is cotangent. All right. So now let's actually work on solving, setting up ratios and then solving, actually. So in this first example, you have, you've been asked to find the exact value of all 6 trig functions. Okay, so when you see that phrase, exact value, when you are doing, when you have trig questions, what that means is do not round to a decimal. You want to leave your answers as radicals. Radicals are roots. When you have like a square root, that's a radical. So leave the radicals in your answer if they're not, like, if you get square root of 12, that's not a perfect square. Okay, you leave it as a radical instead of getting it as a decimal. Okay, now if you can simplify the radical, you want to do that. We'll talk about that when we get more into a problem. All right, so here we've got a triangle from theta. This would be my opposite, adjacent, and hypotenuse. Y'all agree with labeling? Okay, I I can go ahead and give sine. It says give all 6 trig ratios. So I'm going to write all 6 of them out here. So I want to be able to give sine, cosine, and tangent. And the reciprocals. So I can go ahead and give sine with what I have here, because sine is O over H. That's 4 over 7. Easy peasy. What would cosecant be? What's the reciprocal of that? Good. All right, on a roll. Now I go over here and I say, okay, what's cosine? Cosine is A over H. Oh, crap, I don't know A. So I've got some extra work I have to do before I can answer this one. I can go ahead and put H as 7. Okay, but I need to find A before I can answer these others because they all have A in them. Okay, so I'm going to have to decide when I know 2 sides of a right triangle, how do I find the third? Yeah, Pythagorean theorem. What is Pythagorean theorem? What's the formula? Okay, does it matter what sides are A, B, and C? The A and the B are the legs, and C has to be the hypotenuse, right? So I'm missing A. The other leg is 4, and the hypotenuse is 7. So I would have to solve for A, I need to subtract the 16 over. How do I get rid of that squared? Take the square root. So A is the square root of 33. And I'm going to leave it as the radical because it said exact answers. I'm not going to get a decimal there. So this side is square root of 33. Now, what I said earlier is if you can reduce your radical, you want to do that. Okay. If you remember from geometry, or excuse me, algebra 2, reducing radicals, you would make a factor tree. You say, okay, what are the factors of 33? 3 and 11, right? And then if you could break any of those down, you would keep doing it. And you looked for pairs that you could pull out of the radical. Well, 11 and 3 are both prime. I can't factor those anymore, right? And none of them have a pair, so nothing gets to get pulled out. This one does not reduce. Okay, so this one doesn't reduce, so we just leave it as square root of 33. Okay, so now I'm ready. I can put that as my A, and I have my cosine ratio, so I'm good. Okay, now secant would be what? If it's the reciprocal of cosine, what would secant be? Good. Now, another thing you may or may not remember from Algebra 2 is that we do not leave radicals in the denominator, okay? This answer is not rationalized, okay? We have to rationalize the denominator. That means get rid of the radical, the square root in the denominator. Does anybody remember how to do that? Yep. So whatever the radical is that you're trying to get rid of, you multiply by it. So I'm going to multiply by square root of 33. And the reason is when I multiply something by itself, what is that called? What am I doing to that number?
Squaring.
I'm squaring it. And isn't squaring the opposite of square root?
Yep.
So this is how I get rid of the square root. Okay, I multiply this by itself and it comes out to just the 33. The square root's gone. Does that make sense? Because what you're doing is multiplying 33 times 33 and then taking the square root, which comes out to just 33. Okay, now I can't do that just to the denominator because I would be completely changing my number. I can't just change the answer. So to keep it the same ratio, I have to multiply the numerator by the same number, square root of 33. So 7 times square root of 33 is just 7 square root of 33. So that is my secant value, rationalized. Now, if those numbers, here it's 7 and 33, if that could reduce, you should reduce it. Like if that was a 7 and a 35, and I could reduce it because 7 goes into 35, then I would. But these don't have any common factors. I can't reduce that. Okay, so that's my answer. Now, essentially what I did, what's square root of 3 over square root of 33? What's anything divided by itself? That's just a 1. So really, I just multiplied by 1. So this number, if you were to plug this in the calculator and you were to plug this in the calculator, you get the exact same number because I didn't change the number. So when you're practicing and you're rationalizing, if you're not sure if you're doing it right, that's a way you can check yourself. Put your answer in before you rationalized and see what that is as a decimal. And then put your answer once you did rationalize and see if they're exactly the same. They should be exactly the same. Okay, that's a good way to check yourself. All right, then back to tangent down here. What is the tangent ratio? Opposite over adjacent. So what is that here in this triangle? So again, I have the denominator with a radical that I want to get rid of. You do not have to show this work every single time you rationalize. Once you have the hang of this and you understand the process, you're going to be able to know, oh, I just need to move that to the numerator and change my denominator not to have the radical. So you can jump straight to saying that's 4 root 33 over 33. And that 4 and 33 also do not reduce. So that's it. That's as much as I can reduce that. Now, cotangent is the reciprocal of tangent. If I flip this answer, 4 root 33 over 33, aren't I just putting a radical right back into the denominator? And then I would have to rationalize again and simplify because I've got these extra numbers in it. Don't do that. If you had to rationalize your value, that's not what you want to flip for the reciprocal. You want to flip the way that you originally wrote it, because when I flip that, I don't have to rationalize now. It's good to go. Does that make sense? So if you want to make a little note of that somewhere or somehow, saying this is the one that I flipped. So flip the original, not the rationalized one. Does that make sense to everybody? Okay. All right, next example, we are actually now going to do some solving. We aren't just asked for the trig values, we're asked to find missing parts of the triangle. Okay, so we want to start by labeling our triangle with O, A, and H. So from theta, this is the opposite side is the 7. The adjacent side is side BC, and the hypotenuse is side AC. Okay, they tell us that theta is 49, so I can go ahead and label that here. This is 49 degrees in this corner. And they want us to find AC. So AC is this one here, which is the H. Okay, I want to know AC. And I'm given O. What trig function puts O and H together? Sine. So you label your triangle and then you determine, what am I looking for? What do I know? what trig function uses those? So O and H is sine. So I'm going to set up a sine ratio, a sine trig function. And then I'm going to plug in what I know. Whenever you set up your trig, you've got three pieces. You've got the angle and two sides. Only one of those three pieces can be missing. You have to know two of the three for this to work. I do know the angle. They told us it's 49. I know the opposite side is 7. So my missing piece is the hypotenuse. That's my x. So far, so good? Now, if you remember on the check for understanding questions yesterday on the getting triggy with it that we went through, when we were missing the denominator, I went through and I showed you, you would have to multiply the x over to the other side so that it's out of the denominator. And then you would have to divide the trig function over to get the x by itself. But I told you, you're not going to have to do that work every single time. If you just understand that these two pieces, the trig function and the x, those just end up switching spots. So you can just rewrite it as x equals sine 7 divided by sine of 49. So those two, when the denominator is missing, you end up doing division. The denominator missing, divide, dd. Looking for a denominator, you divide. So then this is a calculator question. And remember, we want to make sure our calculator is in degree mode. If you're using a TI like 83, 84, whatever, the mode button right here it says radian and degree. You want to make sure degree is highlighted. If it's not, if it looks like this and radian is highlighted, you just use your arrow keys and go down and over to degree and hit enter, and it highlights degree and you're in degree mode. Okay, if you are using the Desmos, which is, I would use the Desmos Scientific. You're not going to need graphing for a while now with these next couple units. So the scientific calculator looks like this and it has this keyboard at the bottom. There's this little toggle right here. It says DEG. That means you're in degree mode. If you click it and it flips over and it says RAD, you're in radian mode. So you want to make sure DEG is showing, so you're in degree mode if you're using the Desmos calculator. Okay, so you can use Desmos or you can use a graphing calculator, or a lot of you have this, the TI graphing emulator on your phone as an app, the Calc 84 app. You still, on that, if that's what you're using, you would go to mode and make sure you're in degree mode. So once you've made sure you're in the right mode, then we're ready to type this in. 7 divided by sine of 49. Whenever you hit sine, cosine, or tangent, a parenthesis automatically opens. So you have to close that then. Okay, and remember sine, cosine, and tangent are right here, just 2 rows above the top numbers. Okay, and then that is 9.28 approximately. We're just going to go to the hundredth spot. So 9.28. And that was side AC. Okay, then they also asked us to find BC. So side BC, that's the adjacent side here. That's A. So again, I'm going to say, okay, I know O, and I want to know A. So what trig function puts O and A together? So I'm going to set up a tangent function. And I'm going to plug in what I know, which is the 49 for the angle, 7 for the O. And so I'm missing the denominator again. So the same thing's going to happen. The trig function and the denominator just switch spots. So it's almost the exact same thing. It's just tangent instead of sine. So I go back to my calculator. 7 divided by tangent of 49. And that's approximately 6.09. Remember that 5, if the next digit's 5 or higher, it rounds this up. So 6.09 for this side length. Now, ask yourself, are these numbers realistic? Does it make sense that this hypotenuse came out to be bigger than the 7? Yeah, it does. Okay. Does it make sense that this side length came out to be less than 7? And that one, you can double check it. If you have a 90-degree angle here, the acute angles have to split the other 90, right? So if this is 49 degrees, that leaves 41 degrees for this angle. So this is the smallest angle, right? What? That's okay. This is the smallest angle. So the smallest side should be across from it. So it does make sense that this was less than 7. And it does make sense that the hypotenuse was bigger than 7 because the hypotenuse has to be the biggest side. So you can always check that your answers make sense. The other thing you can do to check when you're finding missing sides is Pythagorean theorem. You could go in and say, okay, a squared plus b squared must equal c squared, right? So I got 6.09 squared plus 7 squared. 7 was the other leg. Okay, and then we said the hypotenuse came out to 9.28. So 9.28 squared. Yeah, those came out the same. Now, it's not exact decimals because these are rounded numbers, right? We rounded those, so it's not exact, but pretty darn close. So Pythagorean theorem checks out those side lengths that we got. Those make sense. Now, I always have people say, why did I have to do trig here to find the third side? When I know 2 sides, why couldn't I just do Pythagorean theorem to find the third? And technically you could have. However, remember we talked about in the previous unit, when there's more than one way to solve something, I would always use the way that uses the given information from the problem rather than information that we calculated. Because if you made a mistake in the first step, and then you're using that wrong answer in your second step, you're definitely going to get it wrong. Okay, but doing it this way, going back to use the given information of 7 and 49 degrees, even if you made a mistake calculating this one, you could still get this one right. Y'all remember that conversation? So that's the same reason I would give here for using trig instead of Pythagorean theorem. The other reason is if you use Pythagorean theorem, you're probably going to use this rounded number and it's going to throw your decimal off slightly. This is a more accurate answer because we didn't use rounded numbers in our problem. Okay. All right. So on example 3, a similar problem. They want the 2 missing sides. You're given one side and then they tell you theta is 40. So we know that the angle is 40 degrees. Opposite that would be the YZ. Adjacent to that would be this XY. And then the hypotenuse is the 10, the side that you know. All right. So I'm going to find XY first. So XY, that's the adjacent side. So I know the adjacent and I want to know the adjacent and I know the hypotenuse. What trig function puts A and H together? So this time I'm using cosine. So of the three, I know the angle is 40. I know the hypotenuse is 10. So what's different in this problem than the last one? Yeah, what you're missing is the numerator instead of the denominator. So when we were missing the denominator, we divide. When we're missing the numerator, what are we going to do? Yeah, we just multiply the 10 over. So missing the denominator, you divide. Missing the numerator, you multiply. So now it's a calculator problem. 10 cosine of 40. So that's approximately 7.66. That's this side here. Okay, and then the next side that they ask for is YZ, which is O. So when I know the opposite side, or I want the opposite side, and I know the hypotenuse, what puts O and H together? Sine. Very good. So I plug in, the angle is 40. The hypotenuse is 10. I'm missing the numerator again, so I just multiply 10 times sine of 40. And that's 6.43. Now, does it make sense? Should both of those sides come out to be less than 10? Yes, because 10 was the hypotenuse. The hypotenuse has to be the longest. So it makes sense that these came out smaller. And then if you wanted to, you could go do Pythagorean theorem and check. Does 7.66 squared plus 6.43 squared give me close to 100? Because 10 squared would be 100, right? And it does. All right, last but not least, I am now looking for a missing angle. So they don't tell us theta, they give us two sides and ask us to find theta. So if I label OA and H here, what trig function should I use to solve this one? What do you think? Say again? Yeah, it's got to be tangent because like I said, you can only have one missing piece and it's the angle. So you have to use the two known sides. You can't use the hypotenuse because you don't know it. So tangent of theta is O over A. So plug in what you know, which is 17 over 23. Now, how do I actually answer this? How do I actually find the angle? That's a great, I got it set up, but what do I do? I could get 17 over 23 as a decimal, but that's not my answer. That's tangent of theta. I want just theta. I don't want tangent of theta. So how do I get that theta by itself? So I heard two answers, so I'm going to go over both of them just to make sure, because I heard divide by tangent. Tangent is not being multiplied by theta. This is tangent of theta. Tangent, sine, and cosine are not numbers. They're operations. So if I click tangent, it automatically opens a parenthesis because I've got to have tangent of something. Tangent does not stand alone. It's not a value. So I can't divide out tangent. The other answer I heard was inverse tangent. And that's what it is. So remember back in Unit 1 when we talked about inverses, we used that little -1 to indicate that it was the inverse. And if you look on the keys for sine, cosine, and tangent above them in blue, is sine with the little -1 power, cosine with the little -1, tangent with the little that's inverse sine, inverse cosine, inverse tangent. And that's what we actually need to do. So I'm going to show you with it written out. I'm going to do inverse tangent of theta. Because what that does, tangent and inverse tangent, that's an opposite operation, and it allows the tangent to go away, and you're left with just the theta. Does that make sense? It's just like when we multiply, we do the opposite by dividing to get rid of it. So the opposite operation for tangent is inverse tangent. Now, what you do to one side, you have to do to the other. So if I do that to the left, I have to do that to the right. Now that gets plugged into the calculator. Now, once you've got the hang of this, you're not going to have to show on the left taking the inverse tangent of tangent. You would be able to jump straight to just say, if this is where you are, you would just say, okay, so theta is inverse tangent of 17/23. This part here where I'm showing that it cancels out on the left, you don't have to show that. If you want, I'm just showing it for the sake of your notes so you understand why we're doing inverse tangent. So in your calculator, that's second tangent to get the inverse tangent of 17/23. And that's approximately 36 degrees. When for side lengths, we are going to hundredths, but when it's an angle measure that you're finding, I'm just going to have you get the nearest degree. So like the nearest whole number. So that's a 0.4. So this is not going to round up. It's going to stay 36. So we're going to say that that's about 36 degrees. Change that to an approximately instead of an equals. Now, ask yourself again, is that realistic? Does that make sense for this angle to be about 36 degrees? If that's 36 degrees, what would have been left for this other angle? So does it make sense that this angle is the smallest angle? Yeah, because 17 is the smallest side, isn't it? And we talked about the smallest angle will be across from the smallest side. Okay, so that does make sense. That's a realistic answer. Y'all feel okay about that? Okay, now I know I said this at the beginning, but I'm going to say it again since for the recording. I'm out Monday for a golf tournament. So what you're going to do, you're going to get a paper that has an exploration on inverse. So similar to this very last example. So that's going to be on paper that you work on. And then you're going to have an online practice assignment in Delta Math. The Delta Math assignment is open now. If you want to get started on it or knock it out this weekend, that's great. Go ahead and do that. It's not due till Wednesday, but if you want to do it now, not wait till Monday, that's fine too. The quizzes that you were assigned on Tuesday is due Monday. So Monday in class, when I have the sub, you can finish or redo your quizzes. If you haven't gotten it up to 100 and you want to try and get 100, you could be redoing your quizzes. There will be the paper for the inverse, and then there will be the online Delta Math that is not due till Wednesday. So you'll have a few options on what you could be working on Monday when I'm out. Are there any questions about that? Okay, so let me stop this recording.